is Roger Green, host of the Surfing the NASH Tsunami podcast. This weekend, we are offering 4 conversations from episode 15, our post-event discussion of the Liver Forum meeting. Since one of the rules for the forum is that all conversation stays in the room, this is a bit different than the way we cover other major events, but I think it's a great conversation. From the vault, we have season 3, episode 26.2, with Quentin Anstee leading the group and considering what a year ago were novel thoughts about best use of NITs. This conversation comes from our review of NITs and path going forward last May. I would discuss the episode, but I think the narrative I have rolling into the episode does better than I'm going to do right now, so just listen all the way through. As you can hear, a lot of really interesting conversations and some novel ideas emerged from the Liver Forum meeting last weekend. It's a lot to take in and some interesting perspectives, so sit back, listen, enjoy, learn, and when you're done, join the dialogue on our LinkedIn discussion group.
Quentin Anstee.
You said something there that I really liked, Stephen, which was that about sustained change and that implication, and almost that you can read a biomarker too soon before it's biologically plausible in some situations, which is an interesting thread to pull on.
Jörn Schattenberg.
Or to put it another way, it has a different meaning if it changes in the first quarter of the treatment versus like the last quarter of the treatment.
Jörn, is it about whether it changes in the first quarter of the treatment or whether it stays changed?
That's the sustained part.
Yeah, which I think is the issue. It's maybe less about when and more about for how long. Quentin, when we talked about this last week, you didn't mention the idea of a Venn diagram, and I'm not sure that's exactly the visualization I've got in mind, but if everything flows, then some things happening early will be predictive of other things happening later. Not perfectly predictive, but predictive. So you would think, because I'm taking this past clinical trial and now I'm starting to think about what happens when you have to treat patients where obviously histopathology is not realistic. Do we have the ability using this kind of thinking to build models and say, well, if you see this at 12, then you can believe you're on the right track. Next, if you see this at 32, then you know you're still on the right track, and then you should see this in a year or something like that.
So I think this is really interesting. The Venn diagram idea I was putting out there was very much thinking at the, rather than an early readout, thinking at the end of a study. So you've done your, let's say, 24 weeks, 48 weeks study. You've got your biopsy results. You've got your basket of biomarkers. Currently, what tends to happen, as we all know, is we present, 23% of people had a one-stage fibrosis improvement in the placebo arm. It was 35% in the treatment arm. Oh, and look, ELF test changed in this many on average, and so on. What I'd like to see is to move it to the individual patient level, much more exacting, and then see, well, how many individuals did we, for example, and I'm just picking these at random, have a histological improvement and an ELF test improvement and a FibroScan improvement, all in that same person at that same point? Because those are individuals I would say you could absolutely bank on having an improvement. Now, the numbers are going to get an awful lot smaller. It's a very conservative approach, which has pros and cons to it. But where you do see it, or 2 out of 3, for example, you would have a greater degree of confidence that you're really moving the needle on those patients.
Stephen Harrison.
Let's drill down on that a little bit. Could we take it a step further and say that you have to have a certain threshold of change in all 3 of those? And here's another concept that maybe is worth a discussion to see if we can mine data that we've already generated. Instead of saying a threshold, for instance, of a 30% relative drop in PDFF or a 17 unit per liter drop in ALT, what if we said you had to have that threshold, but it had to be sustained for 6 months? Can we mine that data retrospectively to see if we get a more precise estimate of histopathologic improvement relative to just saying, yeah, we had this many patients hit this ALT number, and you've already mentioned the PPV for that was 20 to 50% for ALT. But what if it were a sustained ALT drop of 17 for 6 months versus 4 months or 3 months, or just at the end of treatment, it finally made it?
So that's an interesting thought. I've not thought of that, Stephen. You're right. If it implies a biological effect and it is sustained, I think that's quite interesting. There are almost 2 concepts here, aren't there? There's the idea of sustained, and then at the end of a study, there's the idea of mutual corroboration of different biomarkers. The mutual corroboration one was the one I was thinking of because it's possibly the most easy to visualize, to reconcile. But the idea that you have a run-in to an effect on an individual patient level, I think will be very interesting to look at as well, with as you say, an X% drop in ALT if it is sustained, for example.
And we could mine that from lanifibranor, we could mine that from Sema, we could mine it from Regenerate, even elafibranor. We could mine that data.
And I think that would be very, very informative, actually, because it would give you that sort of trajectory to a hard, well, to a strong endpoint.
Louise, you were wanting to throw water on it.
Louise Campbell.
No, I'm not going to throw water on it. I might put petrol on it, but I'm not going to throw water on it. So we're moving. What you're describing is moving. We can take a lot of what we gain from hepatitis C, rapid viral response, looking at different outcomes. In my dissertation, I did very rapid viral response, where you had a complete drop of viral load to undetectable, and you normalised your ALT by week 2. 100% of people responded to treatment. So we can mine some of that information. If we look at, people have commented on FibroScan there. FibroScan will do the stiffness, but once you start to drop the fat, you start to drop the inflammation, the stiffness levels out. Whereas going back with to put a benefit of a biopsy, the one benefit of the biopsies in trial is we know those patients with their FibroScans or their FIB4s have reached that threshold. And I think that's key. We will see a normalisation of ALT in a lot of these patients. But what you should see is the plateauing of the FibroScan as that normalises to be able to get that base. So you can retrospectively mine that data as well as to where did the FibroScan settle and where did that trajectory take you. Because once you get the cap down and the steatosis levels down, it normalises out. We see it in alcohol detoxification, where you start to bring down the alcohol content, you stabilise the kilopascals, it is the fat that continues to drop. But the inflammation has been lost once we've lost the ALTs and they've normalised. So is that sort of paradigm of looking at these three and mining all of it, can you do that? We did it in hepatitis C very successfully, so theory being that potentially yes.
Yeah, hepatitis C is an interesting one. In many ways, it's different to the sort of disease we're dealing with here, just because of the not one single pathogenic feature, but a more complex constellation of features. I think seeing an ALT drop, as Stephen said at the start, and I completely agree with, is biologically very nice to see and very reassuring. But I'm not sure that early ALT drop, other than being nice to see, is necessarily a guarantee of long-term benefit unless it is sustained and unless it reflects further remodeling of the tissue and changes in the pathophysiological processes. So, but the idea of commonality you're talking about there, Louise, ALT coming down, FibroScan coming down in the individual, I think is something that potentially is going to be quite important and quite persuasive as we try to reduce drug failure rates at the end of trials.
And I think that gets to your Venn diagram. If you drop your ALT by 17 units per liter by 4 weeks into treatment, by 12 weeks into treatment, in a 48 or 52-week trial, and then at the end of treatment, that's sustained, and you also have had a 2 kPa change in FibroScan at the end of treatment relative to baseline. So you hit both of those factors, and maybe you throw in a third factor, then relating, we can mine that data. We could say, look, if you have one factor, if you have two factors, if you have three factors, how does that correlate to histopathologic response? So now I see another study that we can do. There's one of the sustainability, and there's another one that says if you hit this factor and this factor and this factor versus 1 versus 2 versus all three, how does that correlate to histopathologic response? And not only that, but that would help inform the FDA about moving away from histology. If we could say with a high degree of confidence that you hit, if you hit 3 of these factors and you hit a magnitude of effect change in each one of those factors, that correlates with a 90% probability of hitting histopathology, the registrational endpoint, we're there.
So exactly, Stephen. I think this is the point. And, to go back to what I said about the positive predictive value of, say, the ALT drop or even PDFF on its own. But what we haven't done is stacked them one on top of the other in the individuals and then looked at the likelihood of having those meaningful improvements. And I think that's the sort of thing we should be interrogating these data sets and modeling.
I've been following you guys a little bit from the outside. I guess really speaks to the point that, each biomarker has a unique ability to connect to some of the pathophysiological relevant processes we're studying in these patients, and the overlap of how much they improve at the same time in one patient is really interesting. I mean, if we look at histology. Histology tells us a number of things, right? It's the ballooning, more or less well quantitated, the fibrosis, the inflammation, and not all biomarkers address all points in liver biopsy. So I think of liver histology. So I think it is difficult for one particular biomarker to assess all these changes. And the combination, or as you discussed, let's say the largening of the Venn diagrams, more of an overlap, response going the same way. This is something attractive and probably tighter linked to histology improvements than a single biomarker.
Go ahead, Stephen. You look like you.
I see several studies coming out for AASLD. I mean, it's not too late to submit a late breaker. Too late to submit a regular abstract, probably, but there's a lot of data that Jörn and Quentin, the three of us, could mine and present. And I like the idea of the sustainability versus an early drop. And I like the idea of stacking. Because at the end of the day, is it 3 that are better than 1? Is 2 just as good as 3? Do you need 4? Because that also gets to your 5th point, Quentin, which is the biomarkers that should be routinely included in every trial. Well, instead of just throwing a dart against a wall and deciding arbitrarily which ones we should include, let's put some science behind it. Let's determine which ones we should include in every trial. Some may move fat, some may work on fibrosis, but at the end of the day, we have a hierarchy of biomarkers that are not used for diagnostics. They're not necessarily used for prognostics. They're used for monitoring therapeutic efficacy. And they may be different, right? All NITs aren't created equal, and they're not all equal for all 3 contexts of use.
Exactly. So it needs to be a basket of them, and we can get this from some of the existing data sets. The problem is that there aren't very many data sets where a range of biomarkers have been systematically assessed, but it's not impossible to look at it. My inclination is that it's going to be a combination of something that measures a physical property, so that's elastography, whether that's MR-based or FibroScan-based. It's something that speaks to collagen turnover. That may be ELF, it may be ProC3, it could be something else. And then potentially something that looks at a biochemical phenomenon. So something as simple as ALT could be one of the features we build into this.
It could be AST. AST could be as good a marker as ELF or ProC3 for fibrosis.
When stacked, you're quite right. So I think these are some interesting concepts that it's worth kicking around, actually.
And now, back to Roger.
We hope you've enjoyed this recording. If you have any questions or comments about the content of this conversation or the entire episode, please put them in the review section of the page from which you downloaded this conversation, or send an email to questions@surfingnash.com. Next week, Donna Cryer will be joining us along with a couple of others to discuss why NASH Day 2023 is so important for the future of how we treat the disease and how we look at it. It's going to be a fantastic conversation. So until then, stay safe, surf on, whatever religion you celebrate. This is an important weekend, so have a good one, and we'll see you next week on the podcast. Bye-bye now.